Okay, so this is a re-recording of an earlier video on autism and genomics. There is a strong hereditary component to autism. However, it is probably polygenic inheritance with environmental triggers. So autism spectrum disorders, as you may know, are developmental disorders that emerge before the age of 3. They have common characteristics, but really they're a lot of different disorders. Prevalence in the United States is 1 in 44 children, boys to girls 4 to 1. And nationwide, we're looking at 2.27% of all boys. So it is a very common disorder, and it does affect boys more than girls. It is a spectrum, which means that there's a wide range of features and degree of function or disability. And when you look at the genetics, you can kind of understand things like communication, socialization, cognition, and motor skills are very complex functions governed by many, many genes. An alteration in one or more of these genes can cause a very variable type of disorder. They were formerly classified as separate disorders such as Asperger's syndrome, pervasive developmental disorder, severe autism, Rett syndrome. Now they sort of fit into one umbrella category because there's so much variation even within those categories. That it's more useful to describe them all as autism spectrum disorders and then classify them according to the level of functioning. So level 1 describes a high level of function with some supports. You might have to adapt the environment or teach the individual some social skills, cues, and help them deal with their sensory regulation issues. But generally, these folks are capable of having relationships, seeking employment, and attaining education. Level 2 requires substantial support. These are the folks that you might see in special education classrooms. They do have severe dysregulation of emotional response in relation to sensory stimulus. They can have very repetitive interests. They can do self-stimulating behaviors. But they can achieve some things with substantial support. They might need aids in the classroom or a smaller classroom or occupational therapy, speech therapy. But they technically, they don't function as high as level 1, but they can achieve some of their milestones with substantial support. Level 3 requires very substantial support. These are folks that may require residential housing or in the home support people who work sort of 24/7. These individuals may have cognitive impairment and a certain degree of intellectual disability on top of the autism spectrum features. They may self-harm, they may harm others, but they require very substantial support to be maintained. Features of autism, these are the things that group all of these disorders under the same umbrella. Social impairment, failure to recognize social cues and to respond appropriately. You may have difficulty decoding facial expressions, body language, and those subtle norms that we sort of absorb when we don't have autism spectrum disorder. Failure to behave according to social norms. They don't seem to understand those small social contracts like personal space or what's appropriate in public versus what's appropriate in private. They may have limited interests or topics of conversation. They may need for example, play might be very restrictive to where instead of building things with blocks, they just bang them together. Topics of conversation, especially in your higher functioning folks, might focus on a very narrow topic of interest that is not of interest to the other people around them. Some behaviors can be socially alienated, especially the self-stimulation behaviors. Communication is also impaired. Now, level 1 might be impaired with nonverbal communication and pragmatic speech. Pragmatic speech is the kind of speech that we use in everyday conversation. They can communicate. They have, at level 1, they have a large vocabulary typically, but understanding the nuances of communication may escape them. Now, at level 2 and 3, you may see people who are nonverbal or who have limited verbal communication skills. And they may answer things sort of inappropriately. You might ask a child at level 2, how was your day at school? And they say, Uno cards. They can't sort of make a sentence and say, oh, it was great. We played Uno with the teacher. They have trouble expressing their thoughts and trouble understanding communication from others. And at level 3, they may be completely nonverbal and just vocalize. Nonverbal communication, such as regulating their own body language or decoding body language from others, regulating the tone or inflection of their voice, is impaired to some extent at all levels. For some folks at levels 2 and 3, communication through electronic devices like an iPad or even a non-electronic device, a low-tech communications board, can help some individuals express what it is they want so that they don't experience the frustration of not being able to communicate their needs or desires. Sensory processing may be insensitive to pain. There are children who appear to be insensitive to pain, and so will do things that are unsafe. Or they may crave excessive stimulation, that they prefer loud noises or tactile input, or a lot of screen time with flashing lights, but many experience ordinary stimuli as painful. Things are too loud, they're too bright, they're too crowded, this tag in my shirt is scratchy, sitting in this chair hurts, and they seek to reduce stimulation, and they may seek to distract themselves from that stimulation. Thinking and cognition, level 1 typically has most higher level cognition intact, but they may have problems with executive function. It's sort of similar to ADHD in that they may have trouble planning and organizing themselves. Long-term projects may require a little support to help them focus. Very similar to attention deficit disorder, and frequently higher levels of autism can be confused with that disorder. The more significant impairment at levels 2 and 3 can impact IQ. The problem is we really don't have a good method of assessing the intellect for people who are autism, because some of the items on a standard IQ test may require pragmatic knowledge of the world that they're missing. So they may have stronger intellects than we think. For example, one of the questions on the Stanford Binet assessment might be, a pencil is to paper as scissors are to, or something like that, and they don't know how to use scissors, so it escapes them. Idioms can be very difficult. Anything that's a figurative speech for folks at level 2 can be really, really tough. And at level 3, usually we do see intellectual disability. A lot of the people who are diagnosed with autism now would just have been classified as intellectual disability or mental retardation and classified along those lines. And now we're realizing that this is more of a sensory language, it's a little more precise. There are sometimes repetitive behaviors that we see frequently. This is called stimming, and it's a way of self-regulating and controlling reactions to sensory input. And it can be anything from playing with your fingers or having to have a rubber band to stretch around, and fidgeting. Fidget toys are usually very helpful, all the way to self-harm, which could be head banging, biting, slapping the self. Hand flapping is really common. It seems to affect like the upper extremities a lot. Spinning to get that input into the nervous system. Stereotyped behaviors of all kinds. Lining up things. So the need for sameness and rigidity and external order can sometimes translate into really tough transitions, and inflexible adherence to a routine, everything the same. Food preferences might be extremely limited. There are some kids who will only eat mashed potatoes or only eat chicken nuggets, and so we have some nutritional problems. Distress at very small changes in caregiving or small changes to routine can cause major distress for folks affected by autism. And then you see sometimes fine motor and gross motor delays. There's something called dyspraxia, the part of the brain that's responsible for muscle memory and motor planning, which is where your nervous system sort of automates things. That's missing. So these kids can appear sometimes clumsy and uncoordinated, and they might experience delay with simple skills like writing with a pencil or coloring or cutting with scissors. Gross motor delays, usually you do see the clumsiness. Occasionally you do see kids who achieve their gross motor delays at an advanced pace, but that's not common. So comorbid conditions with autism, about a third have intellectual disability or at least diagnosed with that. GI and immune disturbances for some reason are very, very common, leading to some theories about the leaky gut, some theories about, early exposure to certain viruses. Frequent ear infections do tend to accompany this disorder, and that's one of those chicken or the egg. Is there one common feature that makes you prone to both? Or do the ear infections and that chronic inflammation trigger some epigenetic change that triggers that autism? Severe headaches and migraines are common with autism spectrum disorder. It is a neurological disorder, so that makes sense. Seizures. Kids with seizure disorders frequently develop symptoms of ADHD and autism. Sleep problems go with the autism, and that's another problem with self-regulation. Eczema and allergies. So there could be some autoimmune stuff going on that triggers an epigenetic change. And then we have psychiatric conditions that are frequently diagnosed alongside autism: ADHD, bipolar disorder, and the schizophrenia spectrum disorders. And it is noted that having a family member with schizophrenia does increase your chances of being diagnosed with an autism spectrum disorder. PICO, which is the eating of non-food substances like paint chips or cornstarch. Other eating disorders, really restrictive eating patterns, poor growth, and inborn errors of metabolism. The error comes first. Those are usually genetic changes like PKU or something like that predispose people to developing autism spectrum disorder or autistic features. Causes, there is no single known cause of autism. Some cases seem to be purely genetic, cases that are related to, say, Fragile X syndrome, which we aren't covering in this class, but that's only about 10 to 20%, and others have a more complex causation. There's thought to be an epigenetic component, and we see that with discordant identical twin studies. The heritability estimate is very, very strong. Heritability means how much of this disorder can you attribute to familial patterns. I think it's about 60 to 90% likely for you to have that, but not 100%. Over 1,000 genes have been implicated as contributors to autism spectrum disorder. There's not one single gene. It's not like cystic fibrosis where you can identify the CFTR gene. There could be many alterations because behavior, cognition, motor planning, executive function, those things, communication, language, they're all governed by many, many different mechanisms, neurotransmitters and enzymes and immune factors. It is associated with advanced parental age, both maternal and paternal. Paternal age does show a very strong relationship with autism spectrum disorder, and again, similar to what we see in de novo mutations for achondroplasia or some of the other disorders. We can see as a man grows older, the telomere length on all of his cells grows shorter, and that increases the risk of breakage or substitution with other genetic material, deletions, duplications, things like that. Family history of schizophrenia is a very strong predictor of autism spectrum in a family. And then there have been noted with genome studies methylation changes to genes. It can happen at any point up until the diagnosis. So gametogenesis, the eggs or the sperm, can have epigenetic markers, those methylation tags, either something's removed or something's added. It can happen to the embryo or fetus during pregnancy, and it can happen in early childhood. And that requires an environmental trigger to switch a gene on or off. Unrelated patients almost never have the same mutations, which again shows you there's not one single silver bullet. Gene variants, methylation factors can account for abnormal signaling in the brain. So something goes wrong, a stimulus seems louder or isn't loud enough, or there's an overreaction to it. But it's common to have de novo mutations where you've never had a case of autism in your family and suddenly you do. This table comes right out of your book. Chromosome abnormalities. Down syndrome is more associated with intellectual disability without autistic features, but in some cases, we do see those repetitive interests, difficulty with communication, difficulty with social interaction. The sex chromosome aneuploidies, at times, you can have a female with Turner syndrome or male with XYY or female with XY, and that person doesn't have any symptoms of autism, or you could see autism spectrum disorder, and it's a little higher of an incidence in that population than it is in the general population. Maternally derived duplication. So Angelman syndrome and Prader-Willi are actually the same genetic. It just depends on which parent you inherit this from. There's an epigenetic marker. Copy number. So if you delete some genetic material off the 15th or 16th chromosome, that is known to be associated with autism. Fragile X, we've already talked about. This is a disorder. Mom's X chromosome, there's a weak point where material with the sequence CGG, those little triplets that we talked about during mutation, it can get repeated, it gets duplicated. It's like something breaks and the body tries to repair it, and then it repeats itself. The number of CGG repeats determines whether or not a boy will have Fragile X syndrome inherited from his mother. It is associated with autism. And there are all of these other disorders that are associated with development of autism, but in most cases of autism spectrum, none of them are present. So environmental causes play a role, but there's a lot more research that needs to be done. Air pollution has probably about the strongest link right now, and when you look at statewide studies, the states with the highest level of air pollutants do also have the highest level of autism spectrum disorder. Pesticides and heavy metals are known to be associated with higher incidence of autism. And then we have some drug exposures, and this is all very tentative because you can't really do a well-controlled randomized study on folks. You can only do really retrospective because it's too dangerous to try and expose some folks to a teratogen and not others. But terbutaline, and that's sort of a chicken and the egg. We gave a lot of terbutaline back in the day to prevent preterm labor. Well, was it the prematurity? Maybe there were some structures in the nervous system that needed more time in utero to develop and more hormonal influence from mom, from her hormones. Or was it the direct effect of having the terbutaline? It's an interesting question. I'm not sure we'll ever get an answer on it. Especially now that we're not using terbutaline as frequently as we were. Valproic acid or Depakote is an anticonvulsant, and that has been associated with higher incidence of autism diagnosis. Acetaminophen is very controversial because it's considered safe in pregnancy, but some studies have shown an association. And again, it's like, could there be, association doesn't mean causing. It doesn't mean the acetaminophen caused it. It could be that mom had influenza and took acetaminophen, and it was the influenza that caused the epigenetic changes. SSRIs have been implicated, but that's a benefit versus risk category because sometimes untreated depression is worse for a fetus than the SSRI. Dietary deficiencies, so things like vitamin D, iron, zinc, copper. Some of those have been implicated. Exposure to elevated steroids or sex hormones like testosterone or cortisol. And there was one researcher who proposed that males are more sensitive to this increase in testosterone or cortisol, and they develop exaggerated characteristics of male brain patterns. Maternal infections and fever have a strong link. They do lead to changes in gene methylation, and genome-wide associated studies have shown some of those changes. High levels of maternal stress because of the release of cortisol is thought to do that. Hypoxia at birth and prematurity, that's what I was talking about with terbutaline. Prematurity, the brain is not really fully ready to be born until at the earliest 37 weeks, but most people at 39 weeks are still a benefit to being pregnant. So any loss of oxygen can cause damage to the structures that signal in the brain. Toxic bucket theory. This is sort of a combination theory, not proven, but that it's not any one thing. It's you're exposed to air pollution, and then you have a deficiency in iron, and then you get the flu, and there's a high level of maternal stress. And at some point, you reach a tipping point at a critical period of brain development when the brain is either growing synapses or pruning them, and that seems to be one of those concepts that the brain has to prune some of those extra connections to make sense of the world. And sometimes some people have theorized that that's what happens. So what does not cause autism? Vaccines do not cause autism. Many studies have shown that. There was only one that ever made a connection, and it was thrown out because it was flawed and based on fraudulent science. Parenting does not cause autism, and it does not aggravate the symptoms. Parents need a lot of support with an autism diagnosis. Their kids don't do any of the things, they don't react to things the way that you can expect, and there's not just one way that kids with autism respond to stress. And so there's no real rule book, so parents need support and guidance. Trends in research, there's still a continuation of whole genome-associated studies. What are the protective factors? Is there an epigenetic diet that you can advise pregnant women to follow that would prevent those methylation changes? Variant identification, if they can find some variants, but with there being thousands of patterns and most of them unique to a family, that doesn't look likely. And also, there are traits of autism spectrum disorder. People at level 1 have made great contributions to the world. So if you were to identify a variation prenatally, you kind of wonder, would we be depriving ourselves of really brilliant individuals? Exploring the connection between ASD and other psychiatric disorders. The discordant identical twin studies are interesting. Now it's a very limited population to find identical twins to begin with, and then one has autism and one does not. But there have been some, and they've shown some very interesting patterns. A lot of it has to do with epigenetics. I know it's like number 4 on the list, but I'm going to call attention to the need to share information. Everyone can find a little piece, all these researchers find a little piece of the puzzle. If there's a collaborative database where things can sort of cross-reference and people can look at it all at once, and there can be systematic reviews and, some community, the scientific community can sort of collaborate on that. It makes things a lot different. Support for individuals and families is important. When you have a diagnosis of autism, it's really important to intervene as early as possible to get the highest level of function you can. So speech therapy, at level 1, we'll focus on pragmatic speech and nonverbal communication. At level 2, it might focus on developing more words. It could involve sign language. And at level 3, getting some comprehension and maybe some electronic tools. Occupational therapy is focused on activities of daily living, including social skills, fine motor skills, gross motor skills. Sensory integration therapy might help. There's also, in education, we have applied behavioral analysis. I won't test on that in the rat. The schools need to be involved, starting with early intervention to intermediate unit, and then, as they get older, having an IEP. Should include social skills training. That's one of the important functions of school. Could include speech, could include occupational therapy, and it may have to adapt education to accommodate for that person's special needs, including organization and planning. Children's hospitals often have autism resource centers. The Autism Society of America and Autism Speaks are valuable resources for people. So that is our presentation on autism. I am sorry that the first version did not have sound, but it's yours now.